Thank you all for coming. For those of you who weren't here this morning, my name is Conor Cunningham. I'm a software architect on the Microsoft SQL Server Core Engine team. I decided I'd like to try to do a talk with one of my friends and colleagues, Thomas Kejser, from the SQL Server CAT team. And the genesis behind this talk idea was sort of an artifact about how Thomas and I work together. And I should explain a little bit. Thomas lives in Europe. He actually lives in London. And I live in Texas. So first thing in the morning, I get up, and I come upstairs, and I sit down, and I start doing my mail, and immediately, Instant Messenger pops up. Thomas has some question, and he wants to argue with me about some way the optimizer works in generating plans, not to his satisfaction, around data warehouse queries. And so then we go back and forth, and it's a very good way for me to wake up in the morning. We have these cool conversations back and forth, and I thought, you know, we should figure out a way to argue in front of a crowd so that you guys can see what sort of design process we're doing, because actually the same conversation kept happening over and over again, and I thought it might be interesting to try to make a talk out of that, and Thomas agreed. So graciously helped put this talk together with me so that we can try to talk to you about what are the things that we see when we basically have to go fix data warehouse systems that haven't been done properly, and what sorts of things you can do when building your own to make it a little bit easier. And our core tenet is if you follow the basic rules, then you may not get it exactly right, but you're not going to be horribly wrong. And then Thomas and I can potentially sleep in a little bit more, which we very much appreciate.
Yeah. So one of the hopes that I also had for the talk was I work a lot in the field, and Conor is directly part of the product group and works with the developers there. So I see some things in the field, some things that either says, why would you design like this? But every now and again you find yourself with that design, and I'll come argue with Conor and say, you actually should make this design pattern work, even though Conor will say, why would you ever do that? But also, I see that there are certain processes that are put around people who work out there in the world with data warehousing problems. So, and some of those processes, you just have to adapt to them, and that's where we have some very interesting discussions.
Right, so this is a buddy talk where we basically have we're going to argue just so you can see the different ways to do it, and let you see what works and what doesn't, and hopefully get some ideas about how you can build your next data warehouse.
Yeah. So yeah, we both built the stuff that runs them, and we actually also try to fix some of the things that have already been built, and that in itself is a bit of a learning process. I think coming from these two different worlds, there really are two different ways to look at how we should be developing a warehouse.
You took out the lion.
No. You wait, the lion will come.
Oh, God. My mistake.
Yeah, so the typical approach that I get when I talk to Conor is I'll tell him I need to build a data warehouse, and Conor says, well, tell me exactly what your data model looks like. So, I don't actually know. I have a rough idea of what it looks like, and we'll talk a bit about that process we typically go through. But very often I don't really know the full details of that. So Hans says, well, how can you then spec the hardware? Well, the situation I'm in is that when I go to a customer, they'll typically have a lead time for acquiring a server that may be 3 months. By the time that I've acquired a server and decided which server I want to acquire, the project should be ready to deploy. So I just don't have the luxury of knowing my model in advance. I sometimes just have to go out and buy a server and hope for the best, which is really what boils down to the CapEx. But of course, we have to agree on things. So we find ourselves in this an interesting theoretical dilemma between the ideal world of knowing everything in advance and building something and then speccing the server, and then the world of actually just having to live out there in the field and living under the sometimes very strange rules you find in IT. The way that I typically see people approach this and that I've seen work is to come up with a rough model. When people come to your IT department and says, we would like you to build us a data warehouse. And IT guy says, so what is the warehouse supposed to do? No, we don't know. Somebody told us that we should build a data warehouse, so we want to build one. Can you please just build one? You need to have that conversation with your business user. The first initial conversation often ends up as essentially a matrix of dimensions you want to analyze by and the typical types of facts that you have out there. If you read the Kimball books, that's what he calls the bus matrix. But essentially, it's just a rough idea of how would you like data to correlate together. What's the rough idea? You show them an ER diagram, and they'll say, no, it's not really the world that I live in. I just want to analyze things. This data modeling thing and diagrams don't really work. So that's typically my starting point. That's really all I have to go by.
I, on the other hand, spend my whole day dreaming about query algebras. So I very much want to know what do you want to solve, and I work from the business problem down. But I also like to say, can I have a model that works with this, and can I have an algebra that works with this? And as a result, I can often get quite specific about what ends up happening with each query up front. And this model here is great for iterating, but it doesn't actually solve the question of how fast will this query run? Can I solve a particular business problem in a certain amount of time? So
Conor throws these things at me, right? He gives me that one, and you show that to a business user, and they're I don't think so.
But this is the conversation we usually have in the morning. Okay, how wide is your fact table, and how many dimensions do you have, and how quickly do they change, and what is your compression factor? And eventually that translates to how many storage bytes do you need, and what your IOPS going to be, and then you can size your data warehouse and figure out approximately how quickly the query might run. Because that's basically where I start. Once you have all of that, then I can answer the question, will the query run quickly? And until I get that much, I can't answer that question. And so Thomas and I often have a little bit of a disconnect, and we usually will resolve it with a bet of some form.
Yeah. And that's when heuristics come in, of course, because when you vet, you need to balance out the risk factors and based on what you know. So while I may not be able to give you all the parameters of this equation, actually typically it won't look like that, it'll look like an Excel spreadsheet instead of that. I can at least give you some rough estimates. So to give you some examples, for example, how large is a measure? How many bytes do I need for a measure? Well, I could analyze the measure, but I don't really know. I haven't even seen the source system at that point. 8 bytes. Good number. How large is the dimension? 4 bytes, approximately. Good number. What compression will I get on warehouse? About a third. I get this question from customers a lot. How much will my database compress? And they actually expect that I have an answer to that question.
Right. Oh, you should.
Oh, yeah.
It's about a third.
Yeah, about a third.
Well, with the column store, actually, it'll be a little bit different, but this is the row store answer. So.
Yeah, that's the row store answer. About a third. But of course, the real answer is you don't know until you try it, which is where we want customers to try these things. But often I don't have that luxury. I have to go by heuristics at this point. But one thing we do agree on is that thing with the 4 bytes over there. And I think that this is one of the things one of the assumptions we just have to make about the warehouse. And I think I can generally agree with Conor on instant keys.
Yes. So one of the key properties that we mentioned about building data warehouses is using surrogate keys. And I mentioned this in the keynote this morning, where you move out larger data and you use smaller numbers. And the reason why you do this is you don't want it to be larger than the register size. And in the case of a 4-byte key, you're actually saying, I don't actually have enough distinct values, more than 2 to the 32 or 2 to the 31, so that I would actually care to store more than 4 bytes when I also store it on disk. So being able to leverage that means that once you start getting your fact table to be extraordinarily large, your I/O rates would be better, and that equation that I eventually have to answer about how quickly can that query execute becomes a whole lot easier. So making these fact tables nice and narrow is a very good design principle, and you should just do it. And if you don't, then you should be questioning why not, because there's really not much good that can come of it.
And that's a discussion that I'll often have, sometimes on behalf of Conor, because he needs that sort of rough estimate. That conversation says, well, if you're insisting on these character keys, because that's the way you think about the world, as character keys, I need to have that argument with the customer and tell them about some of these trade-offs. And sometimes that requires me to go back to the basics and saying, this actually means that it will be cheaper in the end.
Right. Even with just 2-byte characters, Unicode, so it would fit in 4 bytes on disk. The actual amount of bytes to compare that is not one instruction. We have to go figure out the collation, we have to go load up the sort tables, we have to figure out exactly how each of those strings compares, and often it can be 100 instructions instead of 1. And if you start doing that each and every row, you are going to be in trouble for your overall execution speed, because your CPU is already going to be pegged, and now you're not helping yourself anymore.
And that's an argument I can actually relate to when Conor puts it up there, because that translates to something that my customers care a lot about, namely the costs. So I can start having that discussion to say, we may not know exactly what the price of your warehouse will be, but if you follow this design principle, it will be cheaper. And that rings true with a lot of customers. But then now we have a rough idea of where we are in the sizes. It's probably not accurate, but we need to buy the hardware because the project is starting now, and we can't wait for that hardware resourcing to arrive. So what do? We
guess.
We guess. Yeah. We guess. Microsoft helps you guess, actually. It helps you guess in the way that we have some rough guidance architecture that says if you're in this type of range, we have a solution for you. It's a solution that we've tuned for you. We've given you guidance already on how to set that solution up, because we've seen this problem a lot of times. We know approximately what a machine needs to look like. So we'll have these sort of ranges that we fall into. We have a fast track range, which is a single system image. We have, with a single machine, we have the PDW, which is a scale-out system. And also be a little bit careful when you read the sales material. They'll sometimes quote you the after compression ratio, and guess what? They'll use the third number too. Mm-hmm. So that's sort of the space we fall into when the customer says, what should I buy? Probably one of these, approximately based on the rough estimation of how much storage you need.
So what happens when we mess up?
Yeah, well, what happens when we mess up is often that's too late, and we need to come up with alternative solutions, because now we bought the hardware, and we need to start adjusting the hardware setup. That might not be possible. If you have a PDW, you have elastic scale, and you can go out and buy yourself another rack. If you have a fast track, you're kind of stuck, and the best solution typically is to start modifying the requirements. But that's a conversation you can have with the business users at that point.
So you can make your data warehouse a data mart and scope it to a smaller set, or you can hold less data, or you can change the grain of your data and ultimately try to make it fit into that database that you just bought.
That's typically what I would have to do. I'll have to reduce the grain. I'll have to reduce the history that I'm holding. That's just my best bet, because I've already bought the hardware.
Or you can go back for more money, of course.
Oh, yes, but that's very hard typically. It's hard to do that late in the project. But what should we expect from the fast track guidance? So this is really the picture of what you should be doing. Conor, would you like to talk to that one?
Yes. So this is a pretty easy slide. We write down how you should do it, and you should follow the guidance, period. It sounds pretty simple, but basically one of the main problems you have in figuring out how to configure your system is, if you were to buy your own, you have to buy the storage subsystem. You have to buy the I/O interface. You have to figure out how that aligns with all the CPUs that you're setting up. You have to make sure that all the stuff you buy is all tuned so there's no bottlenecks. You're going to spend months trying to figure out exactly what all those bottlenecks are. And frankly, probably not everyone here wants to do that, or maybe not have the skill set to do it. We have some people who have gone through and done that for the appliances. We've already pre-tuned them, and that tends to make things a lot easier. We want to make it easy for you to deploy data warehousing, and we've had some people go through and spend a bunch of time making sure they make the exact trade-offs for each of the physical hardware choices we've made and each parts of that architecture to make that work better.
Yeah, and that's all fine, Conor, and that's a good argument. But the issue that I have is I have to deal with the SAN mafia. And they don't really buy these things that easy. They will not buy this argument. Yeah, that's fine, Microsoft done some tuning. But just because Microsoft says it doesn't mean that it's true, right?
I don't have to deal with the SAN mafia quite as much as Thomas, obviously.
I need to have a conversation about why it works. And that's where we get into the deeper fast track guidance. I need to have a conversation with the SAN guys, with the network guys, with the server team. Maybe they don't even have a fast track server on their product list of approved servers that they're allowed to buy, because they haven't tested that server yet. So all of these things I have to have a conversation about. I have to have a conversation about why should you have the right storage system? What does it mean to have the right storage system? What sort of gigabytes per second should you be expecting from one of these engines? How many HPA adapters, if you are going to be using fibers, will you want to plug into that? What does that mean compared to your SAN infrastructure? How does that fit into your server infrastructure? How big is the server actually in your rack? These types of conversations I will often have to have. They won't just buy Fast Track because we tell them to.
Right. Well, the point is we don't care if you buy Fast Track per se, but if you're not willing to go through and do all this analysis yourself, then you either need to buy the Fast Track thing, or you need to have the conversation with the SAN guy who's yelling at you to ask him if he's done all that with the hardware that you're about to buy, so that whatever you end up getting is tuned, and you're not just making a business decision because someone happens to be a very good salesperson. I have to fix so many cases where they come in with an underutilized or overutilized storage subsystem, and they want me to do magic in the query plans. And after a while, there's only so much magic we can do. The magic we did this morning, that was good magic. But I can't pull that out of a hat after RTM.
Yeah, so actually my hope is that I can make Conor's life easier by giving him something that's balanced. It also gives me a better position to argue with Conor. Because if I can go into a customer and get one of these installations in there that I know doesn't have a bottleneck that I need to care about, I can go to Conor and say, I have a perfectly configured system and you're still doing something wrong.
So that's when I have to pay attention to Thomas. And we spend quite a bit of time working together as soon as we find one of these cases because we hit. There's no excuses anymore. And I can go back to my bosses and say, we've got a problem in how we build these kinds of query plans, or in this sort of scenario, slowly changing dimensions, or if the dimension's too large, or if it's configured wrong. Then all of a sudden, we can't really say the customer did something wrong. Then I have work to do for the next release. And we're constantly looking for those. And that's a great day when Thomas can come yell at me and I have to be speechless.
Yeah,
which is a rare occurrence, I suppose.
It doesn't happen that often, I'm afraid. Speechless is not something that I would use for you, Conor. So what do we do now that we have the hardware? So typically we approach this as building a prototype model. We basically need a rough idea of what it is that we want to build. We have this matrix that shows us sort of what the business wants. We need to get closer to that number that Conor needs to get his full knowledge of the query. And very often this means that I have to hack together a schema real fast. I need to do some data analysis. Nearly every data warehouse I've worked on has a data quality problem. It's just business users will tell you that they don't have a data quality problem because that's the way they're set up. We don't have a data quality with our source systems. You don't have a data quality system with your source system. You don't know you have a data quality with your source system is more likely the right answer. Nearly every system has a quality issue. We have a tool for that, data quality services, that actually allows you to analyze it. And it's very good to run it early in the project to get an idea of the scope of the problem. Maybe you're just that one customer out of a million that doesn't have the problem. And that's good to know all too. Excel is a good tool for that. I just like doing the simple thing. Just put it into Excel, have a look at what the data actually looks like. Most likely you will find something that's surprising in there. And the reason that we have this tip here is that you need to think as this prototype as something you will be throwing away. This is an exploration. I think you would call it agile development, really.
Pretty much, it's the equivalent of agile development. Yeah. What you want to do is get all the way to the report that you generate for the output of the data warehouse. Generate it on a subset of the data, a small subset of the data. Generate the report, give it to your boss or whoever asked for it, and they're going to immediately tell you, well, this isn't what I wanted, right? And then you can figure out what they really needed without spending a whole lot of time trying to tune a big system. So we haven't spent a lot of time tuning the storage subsystem because we just followed the best practices. Now we've gone through and taken a day's worth of data or a week's worth of data and generated our first report. Now we can refine those reports, and you should go through and keep doing that until you feel that you're getting pretty close. The requirements aren't changing that much. Or the trade-offs that you have to make are such that someone's not willing to pay for it anymore. Then, at that point, throw away everything you've done and start building the real one.
Oh, yeah. There's a lot of tricks you can use here. First of all, we have very good tools to hack up a prototype schema very fast. If you're running pre-2000, SQL Server Management Studio still has that nice little old visual designer where you can drag in tables and drop the foreign key constraints and make it look quite nice. I find that to be actually a very nice way to hack something together in a hurry. But one of the things that you definitely learn from the product group is if you're not source controlling things, chances are things will go wrong along the way. And with the data tools in 2012, you actually have a very good way to think of your schema as a piece of code that can be controlled, versioned, you can run diffs on it. It's a much more powerful way to think of designing a database schema.
How many people here have actually used a source control system for a database project? Right.
Quite a lot.
A good number, but not all. This is a practice that I'll suggest, especially for disaster recovery or for compliance reasons. Having the ability to do this is really quite powerful. You don't have to necessarily use any particular source control system. Microsoft ships one, but there are other ones that are available. Getting to the point where you have that available and backed up will mean that whenever someone quits or you have a person who moves on to a new job and then forgets things, you need to have the ability to rebuild that data warehouse whenever it's time to do disaster recovery or upgrade to the next server. And having that source control system takes a little bit of time to get into the methodology of doing it, but I highly recommend it. Because cases where I've seen customers that have a whole bank of servers, and then I go in, I'm supposed to fix this broken live system, and they're losing millions of dollars a day. And I go look at it. The first question I ask is, do you know the state of the server? And I look them in the eye. I look them again in the eye. And it's very rare that they actually look back at me in a confident voice, because they had to call me in anyway, right? It doesn't come to me unless they're already screwed. So I'm supposed to fix this, and they don't know what's going on. So for our future conversation, it would be good if you get to the point where you have that set up. So if you could rebuild a test system from your source control system, that's a really good test. Can you do it? I suspect most of you couldn't. And it's because it's not really a practice we've made easy enough yet. In SQL 2012, these data do tools, what's it now called? The
SQL Server data
tools. Okay, yeah, they keep changing the name. We always get stuck in these code names for like 5 years, and then they throw us up on stage, and we're supposed to know all the marketing names. The X velocity thing, that was last week. I didn't know. And they didn't tell me until Thursday. So ultimately, this thing here on the right, you can do that, get the source control out, try checking it in. You can use the source safe, which is the oldest one that we have from Microsoft, and the new one, which is
Foundation Services.
TFS, which has a version control system. You can use that. It comes in Visual Studio, one of the additions of Visual Studio. Get your boss to buy that and say, hey, I'm going to save your ass by making sure that we can recover from the next large disaster.
Yeah. If you have an organization that understands what source control is, that is. If not, try to start your own repository. At least just run it locally. This is a struggle, exactly this state of the test server. Well, of course, this idea of having a test server that you can actually restore something on and throw the problem.
It's a great idea, yeah.
It's not that common. Very often these customers say, oh, well, yeah, our data warehouse runs on that 4-socket out there somewhere.
Right.
But the test server, we didn't have the money to buy that. So we're running on a 2-socket. Will that be good enough to repro your problem? That's how I often find myself in these
sometimes,
situations.
Maybe. Right, we often will have this. So I think that what you'll find is provisioning hardware is expensive. You'll often have the old generation data warehouse as your test system. And that may not be the best, but it's better than having nothing. And that process of being able to deploy your schema and test it out in pre-production first is still very valuable. So this source control thing goes to that whole life cycle question about how do you make sure that whatever you're changing in your data warehouse, you control. If it gets to the point where you can be very deliberate about those changes, you can make sure that you're not the person having to answer to your boss about why the data warehouse went down.
And of course, you would never do such a thing as alter the schema in production because you're in a hurry to get it through these processes. So we don't do that, obviously, but it does happen out there. Good thing is this data tool actually has the ability to compare two schemas so you know when you're done it. And you can say, oh, wait a minute, this test system that I thought I had that isn't, I thought it was identical to production, it actually isn't. And the ability to compare such things is quite a useful tool. So now that you're building a prototype and we've established that you're going to throw it away, a few tricks you can do. So remember we said you should use integer keys, and doing that requires a bit of ETL logic. So integer keys can take some time to write. One of the reasons people don't do it because it's hard. You have to look things up. Well, if you're just building a prototype, just put a hash function on that. Yeah, you might get a hash collision. There's a small chance of that. Chances are that your data quality is probably a lot worse than your hash collisions. So integer keys just uses a hash function. Pick a good hash function. Now you at least know what your schema should look like. There's this notion of type 1 dimensions. Those are dimensions that don't track history. So business users like to say that they always want to track history. So for example, here's the top one here that you see to the right is a type 1 dimension of me. I live in London at the moment. But business users often want something like the bottom one, where they know where I used to live, so that they can put those data, the facts they have, correlate them to where I used to live. Very often when you're having a conversation with business users about what the data model has to look like, you don't really care about these type 2 dimensions yet. You will potentially care about them, but they take time to get right. And sometimes skipping past that in a prototyping phase is a good idea so that you don't have to have that complexity. I like to use Power Pivot, very nice way to quickly visualize what you're trying to build, show the users what their data actually looks like. You can have a lot of rows in there. Don't make it your data warehouse in the end, but just start like that. And basically, really what you want to do here is conversation. You want to understand the users because they will tell you things. They will tell you about what they really want. And this is probably familiar from some of the code we sometimes release, that we will sometimes have a conversation with them that says, wait a minute, that's not what I actually asked for. There will be visual tools that say, I thought I wanted this, but actually what I really want is this. And you won't know that until you actually see that piece of code and you see that running.
Or their requirements change from the time that you ordered the hardware and you started this process.
That could have happened too. Maybe you got new data. Probably you forgot some data. That matrix you drew in the beginning, most likely not going to be exactly what you thought it would be, which comes back to the model. Now the model changing. Data sizes, another good thing. So what can you do to get the schema? What schema can we design to make Conor's optimizer happy? That's really a key question here.
So the set of things that I do whenever I talk to customers about building data warehouse schemas, it really boils down to a couple of core principles, right? There's this star join pattern that I talked about this morning in the keynote. And in almost all cases, when you're writing report queries off of your data warehouse, you want to see that pattern. It doesn't mean the optimizer always generates exactly the right pattern, but usually it will get pretty close. And most of the things we've been talking about so far are how do we get you pretty close? So by this point, you implement your first prototype schema, and you start running your first real query on it to see, does it work? And you see, what things do I get? Do I get a star schema that's working with a star join, or do I have a problem? So the types of things I typically see are people didn't actually build a star schema. They didn't separate out the dimensions. They are joining dimensions in ways that they shouldn't be joining dimensions to each other, and they're thinking they're snowflake or they're star. They get very confused. But keep it simple. If you just have star, not snowflake, and you're playing with things at this point, you should be able to fix most of those basic things in production and start getting that star join plan. If you're not getting the star join plan, or if the performance of that star join plan is suboptimal, then it starts becoming a question about, well, okay, I'm probably not going to be creating lots of indexes on my fact table. But when it boils down to what are my dimension tables, should I index those? The answer is often, well, yes, if you're going to have restrictions on them, because you want to be able to quickly reduce the amount of rows you have to scan in that dimension. So the cases where we actually yesterday sat down and we argued back and forth about which cases worked and which cases didn't work. And it really boiled down to the section in green and red where we were arguing about sargability. And there is one little problem in our optimizer right now that Thomas helped expose yesterday, which is the ANSI year function is not sargable right now on dimensions. So if
it was
you're
supposed to work, wasn't it?
Yes, Thomas, it's supposed to work. So there are cases where we don't always get it 100% right. So if you're going to go encode your dates, you can either decide to encode them as an integer, which was what Thomas's first advanced suggestion is. And I said, that's just utter nonsense. No one's going to want to write things as big old long numbers of dates. You want to actually use the date types and get things to compile correctly and have syntax checking and the whole like, which was the second case. So I quickly worked through how do you go get that to be sargable, and the second column, the second row, is how you would get that particular year question to be sargable today. The key question is, when you're doing that prototyping, you should be able to ask the question, is it sargable? You can go back and watch my earlier talks on indexing, or look at the blog, or read the SQL Insider's book, or any of the questions on how do I get to be sargable. But equality predicates is pretty much most of the time what you're doing for core things. And if you're just doing inequalities on single dimensions, you should be able to have indexes on your dimensions to be able to get things to be sargable. So that when you're building your when you're building your hash tables to join with the fact table, you're quickly reducing the number of rows. Now, if you're not, it's because you've probably done some function that's not sargable. If you have some weird UDF that you've put into your function, into your query, or you're doing something that's a little advanced, step back. Ask yourself, maybe I shouldn't be doing anything if I'm not following the pattern. You're not going to be able to use the column store thing later anyway if you're not following the pattern. So this is a good time to catch that.
Yeah. And also another thing that I like to do is to use identity and sequences to generate the surrogate keys as I evolve my model towards something that no longer uses hash collisions or has the risk of hash collision. So identity and sequences are actually quite good data types for these things. They have the big advantage of being exactly the integers we like in those fact tables.
How many people are aware of the sequences that we added in SQL 2012? So it's a global version of identity, essentially.
Yeah, you can have a single sequence that's across everything if you want to.
If you don't need it, then just use the identity.
You can just use identity. Identity I need a dimension, which actually I find is often just a lot easier. You just declare it. This is a key, and it has an identity on it. There you go. The thing about foreign key constraints is something that we are often arguing back and forth about. One of the things is that the optimizer does actually use the information, but not in the way that we particularly care that much about in the data warehousing space. So the primary problem about foreign keys, sorry, pun, is that you it takes longer to insert rows. And I care a lot about that because these data warehouses tend to need to insert a lot of rows. So I like to declare the key and says there is a foreign key constraint between this fact key and the dimension primary key, but then I disable it. So I don't have to pay the price of inserting, because every time I insert a row and that key has to be checked, that's a cost. And that cost is actually quite high. It goes up by the number of dimensions you have. So instead of checking it in the data model, I like to check it in the ETL code. Right. You do actually use the foreign keys, but for the type of start join patterns, they're not really that important.
Yeah, so the typical place where we would use foreign keys is we enforce them, so we can block you from inserting things that are wrong. But if you're building a data warehouse and you're using the right ETL tools, you can go ahead and double check, since you're splitting the data up already to build the star schema, that the data is actually correct. That avoids that need. So you don't need the database engine to enforce it for you, and you don't need to do all those random IOs potentially to look up those things in the dimension table or the fact table to validate they all exist. Okay. So the next issue is, well, what else can we use the foreign keys for? We can use foreign keys to eliminate some joins in some queries for existence checks. But you're not doing exist queries on this. That's not a pattern that you're going to see in data warehouses. So at the end of the day, it's nice to know that the foreign key is there, but it's not useful to really have unless you can't prove that the data is correct. Yeah. So if you control the ETL process, you can just get rid of it. And then you can always try turning it back on at any time. It'll have to do a scan to see if it's actually correct still. But you don't have to do that work at runtime. And that'll mean that you can get more IOPS, more queries out of your system for the same hardware.
Yeah. We're not just burning CPU cycles, all those precious CPU cycles we just acquired for that. One of the things that Conor spoke about this morning was the notion of not nullable. So that comes back to me. I will have customers who say, well, I'll use null for the unknown key, which you will become quite familiar with as you start designing data warehouses and discovering that your data quality isn't quite what you thought it would be. So you say, oh, well, if I don't know this dimension key, I don't know what that key is, I'll just put a null in there. That's generally a pretty bad practice for performance reasons, first of all, but also there are actually design reasons why it's a bad practice. If you allow your dimensions to be null in your fact table, very typically you'll have more than one unknown. This is the kind of thing that OLTP designers will say, oh, more than one unknown? Null is null, right? But what about dates, for example? The 32nd of March. Are you going to put unknown date in there? That might be date wrong. And then somebody says the date wasn't there. That might be a different type of unknown. No date. Then there's a date that says unlimited into the future. The year 9999. That's another type of unknown. So very often you'll have more than one unknown in a data warehouse. And therefore, using nulls, not just because of its bad performance, but it's actually typically a bad idea to simply allow nulls in your dimension keys. Just turn it off, invent a new key, and say this key is the special key. That means I don't know what date that is.
So this is a good time to mention who gets to talk to your data warehouse, right? Because you're kind of encoding some smarts into the logical and physical model and the data model. And you need to understand, okay, now that we're doing this, how do I query this thing? Because null didn't mean what you meant. At least one person might think null means this, and they're wrong. Do you have to build a translation layer, or do you have to at least inform your users, or do you have to be the person who generates those queries? Because if you don't control that, maybe now is a good time to start setting expectations that customers are going to have to write queries against this data model the way you're setting things up so you can resolve these issues. Because there needs to be a data architect person making the choices whenever possible to make sure they're consistent and to make sure that the data you don't get a year's worth of data in and then you realize it's all junk because you messed up a definition like this.
And you also want to take away any excuses to write outer joins. Because when there's a null in that dimension and somebody joins to that dimension with an inner join, they'll probably be surprised by the results. And then they'll say, well, actually, I wanted that unknown too. I wanted to see that. And then they'll write a left join. And then things get a little bit tricky with the optimizer. So I try to make your life easier like that, actually.
Well, left joins aren't the end of the world, but for what you're doing in the SQL Server 2012 RTM, we don't do column store batch mode on left outer joins. So those would be at the top, and you would have to just have batch mode for the bottom part. So if you recall, you get a big speed up if you get the whole thing to be batch mode. You don't get as much of a speed up if you have to switch back to row mode. All the queries will eventually switch back to row mode at the top because the interface out of the query processor is still using the row mode stuff. But since you're greatly reducing the cardinality of your result set, each operation up, well, left outer join doesn't technically, but there may be a group by later up, for example. Then you often will want to make sure that you're trying to maximize the number of operations that are done in batch mode. And this would be a way to get there. Don't let them do outer joins.
So So why is it that we go down to what is it that makes you optimize? Because you like these star schemas. I like them too for different reasons sometimes, because they're easier to use and easier to maintain. But what is it actually that makes the optimizer really like that?
Right, so let's do a 2-minute statement about what the optimizer grew up doing. For those of you who were here 2 years ago, actually at SQLBits 2 years ago, not specifically here, I did a talk on the optimizer, and I talked sort of about how the whole thing works and what the search space was and how it thinks about query trees and fragments of query trees. And what it boils down to is we had an OLTP engine that we grew up, and eventually we started adding more and more scenarios on it. We added document processing, we added all sorts of notification systems, we added extensibility for different data types, and then we also added all sorts of logic to handle data warehousing queries. Data warehousing queries have this really neat property that once you follow all the rules, then you should pretty much get one plan shape for your select queries. Now there's little nuances around the edges, but pretty close to one plan shape.
Yeah, and that's actually what I expect, and I'll typically be arguing. If I don't get that plan shape, that's exactly when I'll have that argument.
Thomas and I have big, long conversations about specific query plans and why they are not the plan shape that he wants. And the reason is because if you get that join all the dimension tables, hash join, parallel, scan fact table plan, then you can pretty much predict how quickly things will run. And that will make your life a whole lot easier, because when you're trying to plan, you don't have to really think that hard about, oh, well, the optimizer's hard. Let's go see if we can find Conor at a conference and corner him somewhere and ask him a question about something that I can't possibly answer without seeing your database. Ultimately, what you want instead is to say, get out of that mode where it's trying to be a general purpose optimizer and work into this mode where we say, hey, look, here's the pattern. We have a really big table. All the joins are equijoins on single column dimensions, and we probably don't look at whether or not they're named fact and dim, but I really want to, because it's actually that valuable. Customer expectations around data warehousing are very different than the general purpose one. And whenever the optimizer gets confused because you do something too far afield, then it'll jump back into that regular mode. And that's when you start seeing plan shapes all over the place. We'll go search all sorts of different kinds of join algorithms, not just hash. We'll consider all sorts of different join orders, including ones that might scan the fact table many, many times. And if we have incorrect estimates for any of the cardinality guesses in each parts of the tree, then we could end up with a plan that just either isn't parallel or doesn't do what you want.
Estimates are always perfect, right? Because you set out stats on, right?
Yeah, they're all right.
Yeah.
Perfect.
Yeah.
Never, ever wrong.
Ever wrong, no. That's why I like to actually keep my statistics as part of my ETL flow. I want to know when my statistics get updated. Right. I know you like the autostats and...
No, I'm not actually a huge fan of them myself. But
wonderful.
But for a lot of the bigger environments, as soon as you get to the point where you've been burned by them once or twice, if you have a process where at the middle of the night you load, and you know you're loading, well, that's a pretty good time to update your stats. And then if you're doing it exactly, and that's your only load of the day, you don't need autostats on. You can say, I'm going to create stats exactly at the right time. Now, I'm not necessarily advocating this unless you are going to really do it. Right? You have to be willing to take over that job if you're going to turn off autostats. Yeah. But it is something that gets you in a better spot if you can get there. So once the optimizer has that data, try to figure out, okay, here are the joins. Then it can start picking that store join pattern with higher probability. You're not going to still get it. There's always going to be some plan that's out in the outlier that causes you problems. But if you do what we've done so far in the talk, then your odds are you should expect you're going to get pretty close to that.
Yeah, and getting those stats right is actually my responsibility. If that's wrong, hey, I have a problem.
Then Thomas owes me something to drink.
Oh, yeah. So how do you actually partition and index that model? So now you have a model. It looks like it's doing approximately the right thing, but you still need to put some indexes in there and make it run really fast. So now you're much closer to that wonderful scenario that we wanted in the beginning that says, hey, this is actually what my warehouse looks like. Now I can start estimating how much storage I really need. But you already have the server, and so you can at least have a conversation with the business user about, well, we overshot the goal a little bit with the server. We'll keep some more historical data. Or we undershot the goal a little bit. Well, you asked me to buy the server before I advised you to buy the server. So now we need to have a business conversation about how you will reduce your data sizes and what I can throw away. That's actually a pretty good place to be in, because now you've applied the science and you've had the argument about whether you should be buying the server before or after you're done with the specification. Don't say what I told you so. Have a constructive argument. So yeah, how do you petition? I don't know. My starting point, if I don't know anything more about the data, I just petition by the load window. I like sliding windows.
Yeah, or you can do date ranges, right? It just depends a little bit on how serious you are about it. But how many people do data warehouses and no partitioning? Right? So there's a reasonable number, right? So I typically do partitioning, partially because I helped build the partitioning feature and I'm partial to it, but more specifically from your perspective, it gives you some opportunity once your database grows to a certain size to be able to switch in and out. So if you use the sliding window pattern, you're able to use that to say, you know what, this thing has to be on all the time, and I don't really have a ton of time to take it down to go do my load window at night. Instead of doing the load window at night, you can do it during the day, and you can use switch in, switch out to take old data out and bring the new partition in. So you build it on the side, swap it in.
As long as you just remember that schema M lock.
Right. There are a few cases where super high-end customers can have locks trying to get that in and out, but there are ways to make this work, right? You can quiesce the customers coming in for a brief period of time in order to avoid that problem, and life is okay at that point.
It's just so much more manageable with petitions. And another thing that I like petitioning for is I think of petitions as a coarse index. I had a good question here in the clinic the other day. It says, how should I petition my SQL Server database if all I want to do is to feed a cube? Well, partition it the same way that you're partitioning the cube, because now you actually have a coarse-grained index. The partition will be eliminated. If you do a scan, you no longer do a full table scan, you do a partition scan.
Right.
And
in fact, if you look at most recent versions of SQL Server, partitioning is modeled as the fake leading key of your index. So if you partition on date and you have an index on name, the optimizer internally actually sees an index on date, comma, name. And so we'll do restrictions on that. And if we actually have to go seek on each partition just because you only give us name, that's fine. We'll do that too. But ultimately, if you say I have an exact date and that targets one partition, it's like a seek. And it's that useful for reducing the data flow during your query. So think of it as an order of magnitude improvement when you can do partition pruning.
yes, and so yeah, the syntax takes a little bit of time to get familiar with, I would admit, but it's I think it's a very, very useful feature. I like to, it's well worth spending a few hours trying out different things, seeing how it works. It's a great feature like that. So, and also you can play around with different types of compression. You can compress old things more than you compress new ones. Though I do tend to be pragmatic about that.
Yeah, you have the opportunity when you use these partitioning models to say, I want to keep new data online in faster spindles, old data on slower spindles, or in a different table. And you can use the partitioning model to allow you to do that, and then you can start doing more advanced things once you get there. So if you want to just say, I want the most recent year of data in my main data warehouse, and I want the older stuff in another data warehouse because I don't query it as often, and I don't want to dedicate the same resources to it, you can do so.
How many people actually do that?
There's a couple, right? We've seen a few. It's definitely, you're getting towards the edges here, right? We're not advocating that you do this unless you have to, of course, but just be aware. These tools are there to help you, and SQL Server has built all this because we want you to be successful using large amounts of data volume. There are customers that come to us and say, hey, the index rebuild takes 2 days. Can you make it go faster? And by the time they get there, the answer is no. No, I can't. You buy new hardware, something, right? If you had partitioned your model so you could rebuild little bits at a time or swap things in and out, then you have a much better chance of succeeding. So just be careful about how big your database is getting before things get out of hand.
Yeah. And this is mostly true for the fact table. When I design these systems, I look at the dimension tables, and generally they're a very, very small part of the entire equation. So I don't bother too much about partitioning those. There are a few exceptions, admittedly, where you do that, but that's not the first place I look.
Yeah.
One of the questions that come up a lot is cluster or heap. And we had some very interesting talk about that yesterday. You want to cluster everything. That was your initial take on it.
Yeah, so usually I'll argue, and this is where we go back and forth over who wins the bet. And the first argument was, hey, you know, heaps are crazy. We don't do all the cleanup on them. They don't even exist in SQL Azure. As a data model premise, you want to do just say, I want clustered indexes, call it good.
Yes.
End of story.
Yeah. Well, you see, the thing is, when you say you don't clean up, yes, it's true that we have forwarding records, but we've just advocated partitioning by the load window, potentially. So if what you're doing is completely discarding a partition and loading a new one in there, I don't care about cleanup records, because I'm only going to be appending. A lot of tables are append only.
Right. So this is where Thomas gets right. So then we said, okay, fine. If you're partitioning and you're using the sliding window scenario, then maybe it's okay for you to use heaps on the box. Of course, you're not trying to build data warehouses on SQL Azure typically right now. And then if you don't have any of those conditions true, then clustered index. But only because Thomas says so, not because Connor's happy with it. It's just, it is slightly faster to load into a heap than a clustered index. And if it matters, you can use it. Remember, Thomas is out there helping the top-end customers all the time. So they usually come to me with something, I'm like, that's not what 80% of the users want. He's like, no, no, no. And then we argue back and forth about what it is. And he's ultimately right. You can get faster performance, because I know he's done it, because he's already sent me the query plan and argued about some spin lock that we need to make faster for him. But ultimately, what you need to do is get it to be good enough for your business. So just use that in mind. If you don't care, make it clustered. If you do care, and you're doing all the sliding window stuff, then you can make it a heap if you need to get that extra little 5 or 10% performance at the end.
Yeah, but you know what? We have this argumentation about on the SQL you should cluster on the date column, but if you're petitioned by the date column at the same time, you actually run the risk of shooting yourself in the foot if you're not careful. And the heap doesn't have that risk.
And the reason for this is there are cases where if the optimizer thinks that the selectivity of a particular part of the plan is really, really small, gets down to one row, we might no longer pick a parallel plan. And that might mean that you don't get that star join plan as often. So when you're validating your schema, you can just go check to see, A, am I getting the star join? And if I'm not, can I go look at the cardinality estimates in the show plan XML or the stats profile output to see what does the optimizer say it's trying to do to give you an option of, okay, why is the plan not parallel at that point? And then you should start complaining loudly to one of us, I guess.
Yeah, and that's actually where I start playing around with the guidance on the cluster index. There are a lot of cases where the cluster index makes sense. But if you're petitioning by date, and you're clustering by dates, and you only have one day in there, well, there'll be one key in each petition in the cluster. That's not a very useful cluster index. And in those cases, I would just think, hey, I'll go with a heap. But very often, there's another key you want to cluster by, too. Yeah. For example, if you have a large customer dimension and you want to find an individual customer, that's a really good example of a good cluster index. And it has a high cardinality inside the petition, and it's much more friendly to the optimizer.
Right, so as you're starting to validate your model at this point, you can see it's all the standard query optimizer problems, and you need to test it out. So having a set of test reports that you prototyped earlier is really, really useful for this.
Oh, yeah.
Because if you don't have this, then you don't have any idea what is right and what is wrong. And if you go play with it and you validate it, then you can set a baseline so later you know if it's not following plan, that you can go back and figure out why.
Yeah. So what about column stores? Well, it's actually, at this point, it's actually not that hard anymore. I'm leaning towards saying, column store on the fact table, every column, done. Keep it simple.
So today in SQL Server 2012, we have secondary indexes for column stores. So you have to create it in addition to your fact table. Now that's okay. It's worth the cost at this point. Right? Later, maybe we can have that not be a requirement. But right now, you have to have this additional space to make the column store work. But we've seen today that it can give you 10, I was actually underselling it, sometimes you can get even more than 10%, 10 times improvement in performance. So the key issue is we've got to the point where we have all the basic design choices made. You've made your star schema correct. You've made all those choices. And guess what? You're really close to the set of restrictions that you need in order to fit into that column store if you follow all these rules, right? You're not doing any crazy types. You've made sure all the nullability choices are as good as they can be. And iterating on that data model helped you do that. So this is why we want you to follow this pattern and get you close when we build new features that give you massive performance improvements.
And you can have that argument with your, if some business user decides to stick their nose into the database and talk you about nullability of columns, you can have that argument now. It's going to be a lot faster if you turn off that null. And you might even be able to prototype how much faster that is going to be. So it's a good point now to wrap up these things, harden your schema, make sure that you now have something that's very close to what the optimal design is, and your business users at this point really shouldn't care because you've already delivered the value to them. Yes. So what should we expect if we get there?
Okay. So we've got a nice little insert, though.
It'll be on the next slide, sorry.
So this is on the next slide. But the star join shape, we have a pattern for you. We've already talked about you want to have that star join pattern for all your queries. If your query isn't getting the star join pattern, ask yourself, does this query make sense? Are you doing equijoins? Are you using all the fact tables? Or are you doing something funny? Do you have any outer joins in it? Probably a bad idea. Are you running any aggregates that seem unnecessary? Most of these data warehouse queries are really, really basic. They use SQL 2000 era functionality in terms of surface area. So follow that. If you don't get parallel plans, don't get hash joins, you're not seeing the bitmaps. We haven't talked about the bitmaps yet. We should explain those briefly.
Oh, yeah, bitmaps.
So in these queries, we have these additional special bitmap operators that get inserted when you're building your dimension tables. And what the bitmaps do, they're like a special extra hash. And we create a bitmap in there, and it's sort of a lossy semi-join. Where what we do is say, okay, all the values we saw here for the join keys, here are the values in this hash table after we hash them, and then we AND all those together for all the different dimensions, and take that set, and when we're scanning the fact table, we push this way down into the fact table scan. So before we even start trying to process rows, we're only qualifying rows that might meet this hash function. So this is another way of basically getting the join to run a lot faster. We push a lot fewer rows through the other operators, and it's an efficient way to reduce overall CPU time. Yeah. We have this in SQL 2008, R2, and 4 for the regular bitmap operator. There's a slightly different one, which is doing the same job in the batch processing stuff now.
Yeah, and the way you can quickly validate if you haven't them is if you go down to the fact scan operator, you'll get this little thing that says pro bitmap on the fact join. So the plan will typically look something like this. That there's this column store index scan down there at the bottom. Great performance boost, and you can see that arrow coming out there might be of different size. If we get the bitmap push down, that arrow at the bottom gets reduced. So that there's not all that stuff that's going into the batch joins. You get some dim scans, maybe some dim seeks. You can start optimizing a lot in your dimensions. Very often, that part at the top of the plan is not worth optimizing that much for. You want your statistics to be right. And if you have a large dimension, you might even want to add some indexes that help seek into those indexes. But don't spend too much time up in that part of the plan. You'll typically not see that that's where the time is going. You'll come through a series of hash joins coming from the bottom and going upwards. And as you go towards the top of the plan, you'll see a reduction of rows coming out of each hash join because we're applying filters from the dimensions. And then finally, you'll get some form of aggregation, and it will spit out the results. So that's roughly the plan you should expect to see if you followed our guidance.
So now you got it. You're going to be angry if you don't get something close to this, right? You're going to blog post about it and go, oh, Connor. And then I'll go back and talk to Campbell, the guy that I work with, and we'll argue instead of Thomas and I arguing.
Oh, yeah. The more plans we can get where you've done all of this. So if you come and say, well, I've this super snowflake schema and everything's normalized and I don't get this plan, it's probably not that much I can do to help you. I can help you design a better data model, and that's my job, not Connor's. But if you're coming to me with a data model that is really well designed, that follow our guidance, and you're still not getting it, then we can start having a conversation about the optimizer doing the right thing or not the right thing.
Is this something we need to create special stats, or is it a bug? That's the kind of question that we usually start asking at that point.
Yeah. So that's when the conversation becomes a lot deeper and a lot more interesting about these things.
Now, to be clear, there are some cases where things get funny. If you have large dimensions at the end and you're joining them, sometimes you see nested loops at the very top instead of hash. So it's not that this is the only plan shape. But if you're not seeing something that smells like this, then you're just way off. There's lots of merge joins and sorts of your fact table. That would be a bad day. Yeah. You don't want to sort a fact table.
Yeah. You want that path, the fact path there at the bottom, you want that path to be fast. You want things to reduce fast. You want to basically make sure that you get the most out of that. So what does that look like for 2008 R2 compared to 2011?
Right. Column store has pretty much the same plan shape. It has slightly different names for some of the operators. The key differences that you'll see boil down to where the exchange operators get placed. And that's because the way that exchange operators work in row mode, it's taking the input source and it's actually saying at the beginning of the query, I've got 4 CPUs, so I'll take A to J and put it here, and each range will go to a different CPU, and then it'll actually hash it out and then move those to different threads and execute subsections of the range. In batch processing, we don't want to actually talk to the other CPU core at all, so we're creating little chunks of work that are handled purely by that CPU. So we make sure all the rows are, all the little batches are separate, and we just push them in the core as far as we can go. So the sections that we want are long chains with no exchange operators. So what we did instead was say, just assume that the whole section is partitioned. We don't really care about the data is really there. We just want to make sure that it's separate enough. Once you get to things like aggregate operators, then you have to figure out how to combine them. And we've done all the magic there. But the main difference being, you'll see slightly different operator names. You'll see batch mode equals yes in the little properties. And then you won't see as many exchange operators until the very top, where there'll be an exchange operator that converts it back into row mode so we can return it back to the user.
Well, sometimes we see them anyway, but there's 0 rows going through them. So that's just something to be aware of. You might see the exchange operator in your actual plan, but if you look at the exchange operator, you'll see that we simply bypass the exchange operator.
Right.
So that the first time you see that, I definitely fell into that one, and then Conor told me how it works, and Susan gave me some background on that, and then, yeah, you learn to just have a double check of those exchange operators and see which ones are actually being used. So
you would look at the actual runtime plan to see that.
Yeah. So I think we have a few more slides about the data maintenance.
Yes.
Statistics, as Conor mentioned, is very important to get them right. Sometimes, especially in fact tables, when you have columns that are correlated, the classic example being that depending on which country you're in, you have different food preferences. As we saw yesterday, we have pub food here in England, and we can get fish and chips. We don't eat that in Denmark. In Denmark, we eat black bread with pate on top of it, and if you come to Germany, maybe you like sausages. So the correlation between a country and the products they buy in that country is typically very, very high. And there are similar examples for most businesses have correlations in their data. Yeah. We actually use those correlations to drive business value. When you have those correlations, and you know you have them, it's very often a good idea to add a composite statistics to the fact table on those columns, so that when they're queried together, we have a better chance of estimating how much data is coming out of that.
So for example, if you're saying, I want a country code equals whatever, and food preference equals whatever, then that's the type of thing that you're looking for. If you see reports that are doing that, having composite statistics will help us in the optimizer determine what should be the output cardinality of those two filters together. If you just have single column statistics, which is what autostats will do, then we'll assume that these are completely independent. We'll say, okay, what is the selectivity of the country code? How many people are from Germany? And then how many people like sausages? And we'll just assume that those are completely independent. And we'll say, no, it's the fractions multiplied together instead of really just the minimum of the two. Yeah. And once we get into that game, you can underestimate how many rows you think you're going to return, and that can start causing some of these plan shape issues. Yeah. So look for the common patterns there for what people are looking at. It's okay to have correlations in your data, and sometimes they're just unavoidable, but getting them right will help improve the optimizer plan quality. Yeah.
When it comes to dimensions, I typically like to just do the auto update on those ones, but the fact tables I like to control myself. So I want to know when the statistics on my fact tables get updated. And one of the reasons I want to know that is that it can take a very long time to run statistics on a fact table. So often I have to come up with a plan on how to maintain fact statistics. Whereas the dimensions tend to be small tables, and you can treat them mostly like other pages. By the exception, I would play around with auto update, but right. It's more the exception than the norm. I get the question about rebuilding index. Anyone here rebuilds indexes automatically every week? Anyone here doesn't want to admit it?
Yeah.
It happens a lot, actually, and I think we're partially to blame, actually. We have maintenance plans that suggest, do you want to rebuild indexes now that you're running CheckDB? So typically in a warehouse, you can get away with rebuilding the indexes and the dimension tables. They're small. But you don't really want to rebuild indexes regularly on a 10 terabyte fact table. You want to have a plan for how you will do that. And typically, that means that you will only rebuild and partitioning becomes very useful here. You will only be rebuilding the indexes on the partitions you changed. You may not even need to rebuild them. If you're constantly adding to the dimension, to the fact table, well, maybe you don't even need to rebuild indexes.
Right. If you eventually age them out, then they go away. You might just say, I'll just keep them that way until they go away.
Yeah. And by goodness, you really should be automating these things. So make this part of it. We are out of time, I'm afraid. We had a little slide about serving the data. We've got a lot of cool tools there. That's the message. We can get that data. Once you have it in that model, getting it to the other tools, to the other data models is easy. So I think that's pretty much our time.
Yep. So thank you very much for coming, and we'll take any questions you have.
Thank you.
Questions? Yes, sir.
What's your feeling on using data type instead of integer for joining to the data type?
What's our feeling on using the data type to join instead of an integer? I sort of take a religious view and say just make everything an integer key for things that could be in dimensions, right? All those keys. Now, it's not as bad as a string, but then you have a question of, well, what if the business requirement changes and now it's no longer date? I need date, time, offset, or something larger that doesn't fit in a register, and it gets a little fuzzier. So date has to have the property, which is 8 bytes, but it doesn't have the precision that you might want. in some cases. So I just do everything as integers, and that way that problem is different. You don't have to, right? I mean, it's not illegal. It won't mess up the query plans. It's just a personal preference.
Yes.
Yes.
Very good design pattern.
Yes. Right.
If you want to shave off that byte, yes, definitely. And if you have a lot of data, there are insurance, for example, is a classic data model that has a lot of dates in their fact table. So it does shave off some storage. Less so with the column stores, though. So that's just something to be aware of. I'm not particularly objecting to the dates. They cost a little bit more, but
yeah, it's not a big deal. The strings are usually much bigger of a problem, but dates, you have flexibility there. As long as you're getting the plan shapes you want, you can be mostly happy with this either way.
There's a flexibility concern, though, which is the you sometimes have a business user that comes to you and says, "No, I don't know which part of February it's in. It's February, and I don't want it to be put on the 1st of February." If you have an integer column, you can invent keys that mean February, have no idea what date in February. You can't do that with a date column, or you can, but you have to get really creative to get that.
Right.
So there's a flexibility concern there.
Other questions? Yes, sir.
In the early part of your presentation, you were talking about appliances and fast-track routines as models for delivery. How are you changing your advice as people start using things like AWS and Azure to create those?
Right, so the question is, we have all these cloud things that are coming. How does that change this appliance guidance? Is that a summary of the question? So I'd say that cloud computing will not probably take over data warehousing first, right? You have huge data volumes, moving data around is very expensive. So I think we have a little bit of time before this becomes a primary concern, although I have seen some people try to do it, including myself, just to see what would happen. And the overall take I'll say right now is if you look at SQL Azure today, queries are not allowed to be super large. You have limits on your transaction volume size. You have limits on how much memory you can use. You don't have parallel query plans, ... So it's really not going to be a great experience right this second with the offering that's there now to do that. Now, can you go host a data warehouse somewhere, if I can generalize your question? The answer is yes, you can if you don't want to have your own infrastructure. I suggest that if you are in the business of buying your own infrastructure, the appliances make your life very, very easy. If you're going to go to a hosting company and start doing this, right now I'd say the question you should ask them is, are you buying one of our appliances? Not because I want to sell our appliances, but just because it's that much easier to get it right once you start treating it as a fixed point in time to let you do it as a design point.
Yeah. And it depends a lot on how much you're sharing with others. I mean, it's the old SAN problem that shows up here. That if you go rent a machine in the cloud, how much I/O are you guaranteed to get from that machine? And that will depend, on where technology is going.
I have a friend of mine who's been doing pretty much this. They do a lot of BI stuff in the cloud, and they use a hosted provider in the United States, and they weren't getting anywhere near the IOPS they wanted. They tried to switch to another one, and then they got charged by the bytes going in and out, and they lost a lot of money, and they were very angry about that. So you just need to be careful because there's a lot of other business issues that you have to kind of work around right now depending on where you are. But going forward, I expect that it'll eventually happen, and it'll be similar, right? These are generalizations of what your core requirements are.
Other questions?
Okay, thank you very much, guys.
Thank you.